half-range Fourier series. It is a special type of a Fourier series where we are considering a limited interval, means we are taking the interval from 0 to n. In case of Fourier series, generally we are taking the interval as minus L to L or A to B, whereas in case of half Fourier range series, we are taking the interval from 0 to L. This series is divided into two parts. One is called the half-range cosine series and second is a half-range sine series. Whereas in full Fourier series, we are taking both the terms cosine and sine. In half-range Fourier series, we have this form, and in half-range sine series, we have this form, where A0 and AN are calculated by this and BN by this. Now the point is, what is the difference between Fourier series and half-range series? In Fourier series, we are taking the interval as metric interval minus L to L, or we can take the function as 0 to L, or we can take the interval as A to B. Whereas in the half-range series, the interval is already specified in the half-range, that is from 0 to L. In this case, the length of the interval is b minus a is equal to 2l, whereas in this case, b minus a is equal to l, and in this case, it is simply b minus a. Whereas in this case, the length of the interval we are taking as a l. Second point is, in the Fourier series, we are calculating depending upon the interval or a function a0, an and bn. Whereas in half-range series, either we will calculate A0 and AN, that is for the cosine series, or BN for sine series. Now there is another difference. In a Fourier series, we have the sine term and a cos term, where it has the angle as 2n pi x by b minus a, that is the length of the interval. Even in this case, same angle we have. Whereas in the half-range series, so rather than taking 2n pi x, it is a n pi x divided by length of the interval, that is b minus a, and in this case the length of the interval is n. And same for the cos term, n pi x divided by the length of the interval, that is n. In Fourier series, you can remember that this period of sine and cos is 2 pi. That's why we are taking a 2 pi. Whereas in half-range series means we are taking the half of the series, means we are taking the half period of the sine and cos. And the half of 2 pi is pi. So that's why we are taking a pi over here rather than 2 pi. These are the basic difference between the Fourier series and half-range series, and depending upon the requirement whether we need a cosine series or a sine series, we can evaluate the required approximation. Let's take this example. Expand this function as a Fourier series in a sine term. It means we are dealing with the half-range series and we need a particularly a sine series. So in sine series, function is approximated as summation n from 1 to infinity bn sine of, rather than 2n pi, it is a n pi into x divided by length of the interval. We can take it as a b minus a. Now observe in this case, the overall interval is 0 to 1. Total length of the interval is 1. So we can write this as equal to summation n from 1 to infinity Fourier coefficient Bn sine of n pi x. Now calculate Bn. Bn is calculated as 2 by length of the interval, in this case is 1, integration from 0 to 1 function into sine of, with the same angle, n pi x. Now, how to evaluate this integration? Since the function is divided into two parts, one is from 0 to half, second is half to 1. So, we will break this integration according to this one. So, this is equal to twice of integration from 0 to half of function. In this case, the function is 1 by 4 minus x into sine of n pi x plus integration from half to 1 of the function x minus 3 by 4 into sine of n pi x. So it's integration with respect to x, and that whole integration is multiplied by 2. Now, how to evaluate this one? So, if you observe that in this case, this is an algebraic function and this is a trigonometric function. Even in this case, this is an algebraic function and this is a trigonometric function. So, we can use the islet in this case. For that, take this as a first function because it is an algebraic, and trigonometric as a second function. Same in this case, this is the first function and this is the second function. So, this is equal to twice of first function as it is integration of sine n pi x is minus cos of n pi x divided by coefficient of x, that is n pi, minus derivative of this term, that is minus 1, integration of this entire term, that negative sign is as it is because it is a constant, divided by n pi is as it is because it is again constant. Now, integration of cos n pi x is sine n pi x divided by the coefficient of x, that is n pi. So, we can take square term. Derivative of minus 1 is 0. It means there is no need to take the next term in this case. This is the value of integration for these two functions from 0 to half, plus in this case x minus 3 by 4 function is as it is. Integration of sine n pi x we have already calculated, that is minus cos of n pi x divided by n pi minus derivative of this term is 1, integration of this term, that is equal to this, we can write minus sine of n pi x divided by n pi square. Limits are 1 by 2 to 1. Now we will substitute the upper limit. When you substitute upper limit means we need to replace x with the half, and for the lower limit x is equal to 0. Similarly, in this case we will replace first x with 1, then we will replace with x is equal to half. By substituting these values we have this form. So this is the value at the upper limit and this is the value at the lower limit. In this case, why we are getting a 0? Because when you put 0 over here, sine 0 is a 0. So overall term is 0. So these are the values at upper limit minus lower limit. So this plus sign is as it is. Now put x is equal to 1. We have this term. And in this case, we have this term. Minus, put x is equal to half. So we have this term from here. Now simplify this. This is equal to twice of negative is a positive. 1 by, that is a 4, n pi is a constant term. Cos of n pi by 2 minus, we have 1 by n pi square into sine of n pi by 2. And in this case, this negative negative is a positive, plus 1 by 4 n pi, and this term is 0. From here, what we have, this is a negative sign, and here we have a positive. So overall is a negative cos of n pi divided by 4 n pi, and here we have positive sine of n pi divided by n pi square. And in this case, negative, 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 overall answer is a negative. 1 by 4n pi cos of n pi by 2. And here negative into positive is a negative. 1 by n pi square sine of n pi by 2. Now observe that this term and this term is same. One term is a positive, another is a negative. So we can cancel it out. Whereas sine n pi is 0. So this is also 0. And in this case, we have minus 1 raised to power n. And these two terms are also same, but they have negative sign. So simplified form of this one is equal to twice of, this is minus 2 times of n pi whole square sine of n pi by 2. Here we have positive 1 by 4 n pi. From here we are getting a minus 1 raised to power n upon 4 n pi. We can further simplify this. We can take n pi outside. So we have 2 upon n pi minus 2 by n pi into sine of n pi by 2 plus 1 by 2 minus 1 raised to power n by 2. And that is the value of Bn in this case. Now final Fourier series is equal to f of x is equal to summation n from 1 to infinity Bn sine of n pi x. So this is equal to summation n from 1 to infinity Bn, that is 2 by n pi into minus 2 by n pi sine of n pi by 2 plus half minus 1 raised to power n by 2 into sine of n pi x. Do not get confused with that. Sine n pi is minus 1 raised to power 2. Because when you put n is equal to 0, we have sine 0. So in this case, we are getting a 0. When you put n is equal to 1, we have sine pi by 2. That is equal to 1. When you take n is equal to 2, we have sine pi, that is also is equal to 0. When you take n is equal to 3, so we have in this case sine 3 pi by 2. This is equal to negative of 1. So it may be 0, may be 1, may be negative of the 1. So we are not getting any journal form this one. So we cannot write this is equal to minus 1 raised to power n always. So it may be 0, may be 1 and may be minus 1. The next example is find the Fourier cosine series of this function. This function is from 0 to 2 the function value is x square. From 2 to 4 the function value is 4. So in this case, how to write the Fourier series? So Fourier series is evaluated as a0 by 2 plus summation n from 1 to infinity an cos of, rather than writing a 2, we will write n pi x because it is a half range series. divided by the length of the interval. Now what is the length of the interval? B minus A. So overall interval 0 to 4. So we can write 4 minus 0 is equal to 4. Now A naught is calculated as 2 by length of the interval 4 integration from 0 to 4 of the function with respect to x. This is equal to 1 by 2 as it is. Now integration is divided into two parts. That is from 0 to 2 the function value is x square. From 2 to 4 the function value is 4. This is equal to 1 by 2. Integration of x square is x cube by 3. Limits are 0 to 2. Plus integration of 4, 4x. Limits of this one is 2 to 4. This is further is equal to 1 by 2. When you put upper limit, we have 8 by 3. Substitute upper limit, that is 8 by 3 minus lower limit 0. That is 8 by 3 in this case, plus upper limit 4 into 4 is 16 minus 4 into 2, that is 8. So we are getting in this case answer as a 8. Final value in this case is equal to 16 by 3. Now calculate an. An is calculated as 2 by length of the interval, that is 4, integration from 0 to 4 of the function into cos of n pi x divided by length of the interval, integration with respect to x. Again we will split this integration into two parts. From 0 to 2 the function is x square, and from 2 to 4 the function is 4, and the rest of the terms are as it is. Now how to evaluate this integration? Again we are getting a two function of x. This is the algebraic function and this is a trigonometric function. So we will take the algebraic function as a first function and trigonometric as a second function using a isolate. Whereas in this case we are only getting a one function of x, that is a cos. So we can directly take its integration. This is equal to half of first integral is equal to x square as it is. Integration of cos is sine n pi by 4 into x divided by the coefficient of x, that is n pi by 4, minus derivative of x square is 2x. Integration of sine is minus cos of n pi by 4 into x divided by n pi by 4. Already n pi by 4 is there, so we can write this is n pi by 4 square plus derivative of this term is 2. Integration of cos, that is a sine n pi by 4 into x divided by the coefficient of x, and that coefficient is already there but 2 times, so we can write n pi by 4 cube, and this negative sign is as it is. Derivative of 2 is 0, so there is no need to take the next term. Limits are 0 to 2 plus, now integration of this term, so this 4 is outside. Integration of cos is, that is sine n pi by 4 into x divided by n pi by 4. Limits are 2 to 4, and this whole term is multiplied by half. This is equal to half of, substitute upper limit. When you substitute upper limit, we have 4 into sine of n pi by 4 into 2. So we are getting in this case n pi by 2. Now this term can be written as in a reverse form, that is 4 by n pi, because it is in a denominator. Negative negative is a positive. X is replaced by 2. We have 4. This term is reversed, so we have 4 by n pi square cos of n pi by 2, because we have replaced x by 2 in this case, and that 2 is cancelled out with the help of this 4, and we have 2 in this case. Positive negative negative, twice of this term is written as 4 by n pi whole cube into sine of n pi by 2. That is the value at the upper limit. So we can write this as upper limit value minus lower limit. When you put 0, we have sine 0 into 0, 0. In this case, we have x. So when you replace x with 0, the whole term gets 0. And in this case, sine 0 is 0. So lower limit in this case is 0. Plus. And in this case, what is the value? Plus 4 times of. This term is constant, so we can take outside and we can write this as 4 by n pi. Substitute upper limit. When you put 4 in place of x, we have sine n pi minus, put lower limit, we have sine n pi by 2. Simplify this, we have 1 by 2. This term is written as 16 by n pi into sine of n pi by 2. Next term is 4 into 4 by n pi whole square cos of n pi by 2 minus 2 times of 4 by n pi cube sine of n pi by 2. This is a plus 16 by n pi. Now if you observe, this term is 0, sine n pi is 0. This term is as it is, minus sine of n pi by 2. From here, this term is get cancelled with this one, because both the terms are same but with opposite sign. And in this case, we cannot cancel these terms. Moreover, we don't have a cos n pi by 2 general value as well as for the sine n pi by 2. So this is equal to 1 by 2 4 into 4 by n pi square cos of n pi by 2 negative sine of 2 into 4 by n pi cube sine n pi by 2. Substitute this an into this Fourier series and substitute a0 is equal to 16 by 3. Then you have a final Fourier series for this function from 0 to 4.